This HydroLesson explores rating curves and synthetic rating curves. Forecast models estimate streamflow, known as discharge. Yet visualizing flood inundation also requires understanding how high the water will rise and how far it will spread across the surrounding terrain. Rating curves determine that critical correlation. A rating curve, shown here in this watershed example, establishes the relationship between discharge, the volume of water flowing through a channel, and stage, the height of the water surface at a given location along a stream. Rating curves are limited to gauged locations. Hydrologists can estimate the height of the water surface, or stage, based on a known discharge. In flood inundation mapping, this same relationship can be applied inversely, where an observed stage can be used to interpolate the rating curve and determine its corresponding discharge. Conventional rating curves are empirical, meaning that they are developed from repeated field measurements collected at stream gauges. Over time, hydrologists record stage and discharge across various flow conditions, plot the stage-discharge pairings, and fit a curve through the data. This curve can then be used to estimate discharge from an observed stage or stage from a known discharge. Due to the shifting nature of river channels over time, these curves require recalibration via regular field updates to remain accurate. Conventional rating curves are reliable, but only exist where stream gauge data is available. To address this limitation, flood inundation mapping uses synthetic rating curves, or SRCs. SRCs leverage terrain data, channel geometry, hydraulic assumptions, and hydraulic equations to estimate the stage-discharge relationship across the broader hydraulic network, including ungaged streams. SRCs are developed using digital elevation models, or DEMs, to initially capture terrain data, including channel and floodplain geometry. Next, the model evaluates a series of potential water levels and calculates the hydraulic properties, such as flow area, wetted perimeter, hydraulic radius, channel slope, and surface roughness for each level. Manning's equation is then applied to these properties to calculate the corresponding discharge for each water level. These stage discharge pairs are typically estimated at 1 foot elevation increments, which are then plotted and connected to produce a continuous stage discharge curve for that specific stream reach. Once the SRC is developed, it becomes a key input to flood inundation mapping. Forecasted discharge is translated into the corresponding stage using the SRC. This stage is then compared to surrounding hand terrain values. Any grid cells at or below the estimated water level are identified and mapped as inundated. In this lesson, we explored how rating curves connect streamflow to water level. Conventional rating curves rely on physical stream gauges, whereas synthetic rating curves use terrain data and hydraulic modeling to estimate flows in ungaged areas. Both are essential for turning streamflow forecasts into actionable flood maps.